Okay.
Yeah, maybe I can say the reason I'm not here actually is because now it will be really, really cool and really deep stuff, which means that I'm going away and Tomáš is coming back because now you will have Monad stuff. And that's something where I'm out, okay? By the way, hi, Mark.
What kind of introduction is this?
All right, hello there. I think I just unmuted my phone now, or my microphone, right? Are we good?
Yes, I think we're good. So
All
we
right.
can get started. I mean, thank you very much for joining, Mark.
Yep.
And I really think Mark has been doing some amazing writing about some of the sort of hard functional abstractions that people know of or sort of have heard about, and don't quite know what to sort of think about them, what to do with them. So Mark's blog has been an amazing place, together with Scott Blushins, for sort of understanding these things. And what I sort of suggested to Mark when we were planning this is that we can turn this into a sort of discussion where, well, I mean, we could almost randomly assign two roles. One person would sort of think, these things you have to learn before you start programming F#. They're amazing. They'll solve all your problems. And the other person will say, oh, what are these free monads? Why do I even have to bother? So we didn't in the end assign this randomly. But I'm going to pick the I don't want to see this role, and Mark is going to start as the enthusiastic one. So, you're so excited about free monads and all these things. Why?
Why? So actually, maybe I should just to be clear, just share my screen here for a little while. Just see if I can figure out how to do that. Let's see. Can we see something now? No, not yet.
There should be a present button, but we have to put you on the screen, which we're going to do as soon as we see it there. But I think you maybe need to do some more clicking in your browser.
Yeah. I'm just wondering if this is all a that was all a UI thing here. I don't know if you can see anything now.
All good.
All good. All right. So just for people who are interested, I do on my blog have a F# free monad recipe, and we can't really see the address here, but it's right here. So blog.plur.dk. That's I promise not to be too blatant about tooting my own horn from now on. But if people are interested, you can go here and have a look. Some of it I actually picked up from Scott Blushins, and some you taught me a lot of things as well. So this one is more like a work of love or of interest, if you will, because the thing, the free monads, the problem that free monads solve is that you can't really interleave pure and impure actions in functional programming. And when you have a language that is very strict about that, which you do when you are working with a language like Haskell, for example, you need to come up with a solution to that sort of problem where you have some pure functions, but then you want to do a call to your database, and then you want to do some more stuff, and then you want to do call a web service, and then you want to do some more stuff that is pure. So you interleave the pure and the impure stuff, and the free monads is a way to get around that problem. So I was just interested in seeing, how you can actually, deal with that in a language like F# as well. So this is mostly just, of academic interest, if you will, because I would probably actually say, in most cases, if you have that problem in F#, F# does have interfaces, and you can use straight, normal dependency injection, and that's going to be way more idiomatic in F# than the free monad stuff is. But it's there and it's possible to do. And if we scroll a little bit in this particular thing here, we can see that there's quite a bit of stuff to actually go through. So this is even just a recipe. So it's not something. This is not reusable code. You have to sort of go through all of this stuff whenever you want to make a free monad. And in Haskell, it's sort of built in that where you can do it in a couple of lines of code. But in F# it actually takes you a lot of things. So this is this one is mostly just out of academic interest, if you will. But I think there are other things that actually are very useful. Maybe I should stop sharing my screen again here, and so that I can see you.
you can leave it, and then we can switch it on and off. But maybe
okay.
if I can ask Roman to put my screen on, then I'll actually have
okay.
one example. So we sort of, wow, this is deep.
Oh.
This is echo content.
So that was that was definitely something that was recursive, at least, which
yeah, I think it probably illustrates
free monads actually are. Free monads actually is a recursive data structure. I'm sorry, I was talking over you.
So I mean, I sort of started with free monads because I think that's well, it makes for a good title, but it's maybe not the most immediately useful thing that people might want. But I've got one interesting example that I think comes up quite often, which is something like this. So this is a bit of code which I'm going to run, and what this does is it. Of course, I'm doing this all bad. So I've got a regular expression to extract an HTML title. I've got a code to download page, and a get title, which then calls download page and matches the regex. And you can run this, and it will give you the title of our conference. If you change it to fsharpConf, then it will say exception. And I think this is one case where that I think comes up practically quite often, where I have exception handling and async, and here I didn't worry about the exception handling. But I've written another version of this, which is using async result, and this is I think one case that we might talk about. So what I'm doing here is I've got download page, which now returns async result, and I sort of handle the. And again, this could be better, but I handle the dotnet sort of exceptions, return OK or error with network error. And then when I download the title, I have to pattern match on the result to see if that worked. And if so, I can do OK and extract the title. And if that fails, I'll say failed to find title. So if I run this now on fsharpConf, I get network error. I run it on fsharpConf, that works. So what's the right sort of how would someone who knows about functional programming do this better?
So I think we need to. So this comes up quite a bit actually, but we need to distinguish between two things, and that is exceptions where you can't really do anything about them, and then all sorts of other errors or off the beaten path kind of branching in code. So something where, let's say you have a network error, which is sort of what you did then in the first example. If you have a network error and you want to access something on the network and the network is down, there's really not a lot you can do about it. So in that case, I think we could make a good case for just keeping, using exceptions because you probably can't handle them anyway, and so you can't really deal with that sort of situation anyway. So that's one kind of bucket, and I think it was Michael Feathers who created or defined those buckets originally, saying, well, they're errors you can't do anything about, and there are errors that you can do about, and then there are bugs, which is sort of like a third thing where the errors that are there but ought not to be there, but then you figure out where to put those. But anyways, so besides from the errors that you can't do about, you might have other things where you actually can do something about them. So this might be something like if instead of just getting a random page on the internet, maybe you want to query a database to see if you have a particular record in the database, or maybe you want to query a web service to see if there's some a REST service and see if there's a resource there. And now you're having a little bit of a different. I'm sorry. No, should I go on? Yeah. All right, good. So in this case, you're having a different problem because it's very likely that the resource that you're querying is not there, and particularly if you're running in a concurrent system, you might actually, the record in the database may have been there just 1 second ago, but then someone else deleted it. So when you make the query, even though you have all the reason in the world to believe that it's there, it's not going to be there. And that's a different situation because you might actually want to do something about that particular problem. So that's one thing. Of course, you can do that with exception handling as well, but I think that one of the problems that you get from exception handling compared to using something like a result type is that in .NET at least, exceptions can be anything. So you can't really tell from any sort of method signature whether or not you are expected to handle anything. Everything can throw a system.exception, and you don't really know what to do with a system exception. Whereas if you have in your type signature a very explicit statement that says, oh, this particular impure action, if you call this, it might return the record that you are querying about, but it might also not do that. Now you know that you have to explicitly deal with that particular edge case, if you will, which is different than just oh, this thing is just going to throw whatever exception. So that's the main reason why I want to distinguish between those things, because this gives us a better grasp on encapsulation, which lots of people think is not important in functional programming, but it actually is. But the whole idea of the encapsulation is that you shouldn't be forced to go and read the implementation code in order to figure out what the edge cases are. You should be able to just walk up to a method or a function and say, I have a pretty good idea about how to interact with this one without knowing all the implementation details. And type signatures are really good for communicating that sort of stuff in a language like F# at least.
This is an interesting sort of point, because I think what you're just sort of describing almost goes against the usual preconceptions that people have about these things, where you think something like sort of monads is an abstract idea that takes you sort of further away from your domain. But what you're just telling us is actually this is a way to sort of, when it matters, put the domain in the types, like through the something like the sort of async of result, where then the error type can actually describe what kind of error happens.
Yeah.
That's rather than making your code more abstract, it's just making your code more concrete.
Oh yeah, absolutely. So you don't, and again, this is one of the things that we probably that you wanted to discuss, was that you don't have to know what a monad is in order to understand what the result type is. That's it turns out that the result type is a monad, as you're well aware of. But when we are being when we're being explicit about this and saying, okay, so this query against the database is going to return a task of a result of something, or a task of an option. It might also be, if you want to query and get, I want a single record from the database, you might just say, okay, so that's going to be a task of an option of, whatever the record is, which means it's expected that you can query for a record that's not there, and you have to explicitly deal with that. At this point, you're not dealing with monads as such. You're just dealing with results or options, and then that particular stack of an option within a task or a result within a task. Still quite explicit, actually, quite concrete.
Well, then the sort of obvious question from an anti-monad person would be, well, why do you keep talking about monads then? What's the big deal? And why do you keep talking about these monad laws? And why should I care about these things if I'm just perfectly happy working with results?
Yeah. I think you can get quite far without actually understanding any of these things. So I was driven by just curiosity, basically. But then I turned out, what I've experienced after figuring all of these things out, because I was curious, I then figured out that there are actually sometimes you run into problems that then the knowledge and the theoretical knowledge you have is helpful. And it's not so much the monad stuff, because the monads are actually pretty nicely encapsulated away in the F# language itself, because you have something like task or async, for example. They're both monads. You have nice computation expression builders for those. So whenever you want to do something that is a little bit out of the ordinary, and you need to combine things, you need to combine several tasks. For example, you want to do a query against a database, and then you want to do a little some stuff with that, and then you want to do maybe save write back to the the database. That's going to be 2 tasks. And one, simple way you can do that is by having a task computation expression, or, an async computation expression. And that hides away a lot of that complexity away from you. So at that point, you don't really need to know anything about monads, which I think is a complement to the design of the language, that it actually allows you to do some quite advanced things without really needing to understand these things, because it just looks like a nice language feature, and then you're productive. But what is one of the times when people start to run into problems then is if you have multiple tasks that you need to combine with options or with results. So, for example, if you run into some sort of n+1 query where you do one query and you get a list of items, and then for each of those lists you want to loop over that list, and then you want to make a new query into a web service or whatever it is. That's not necessarily particularly efficient, but that's the sort of problem you sometimes run into. Now what you end up having is you end up having a task of an enumerable of tasks. So you sort of have this funky nested data structure that's really difficult to figure out, how do I actually work with that, because you somehow a task of a list of tasks. So you need to figure out, okay, how do I get the result? How do I get the list out of the task? But then inside of that list, I have another collection of tasks, and then I need to get the results out of that task. And even if you have a nice computation expression, it's not clear to people how that really, how to go about doing that. And it turns out that there's a standard solution for that. That's called a traversable functor. At least that's what Haskell calls it. And you can take that. You can take that concept and translate it back to F#, which is actually fairly straightforward. And then knowing that that's sort of like the standard response to that sort of problem, you go and say, okay, I have this particular problem. I'm going to need a traverse function here, and then you move on with your life. And I think that's one of the things where knowing a little bit of theory, or at least knowing some standard solutions to things, that helps. We actually do. If people are interested, we can just present this. So I just stopped sharing my screen, so now I have to figure out how to do it again. Let's see, entire screen. I'm just going to do my entire screen here. Let's see. I'm going to hide this.
We'll wait for you to do it, and then we'll put it in the stream straight away.
Yeah. Okay. So let's see if I can. Okay. I just need to see if I can. I hit it somewhere over here. All right, so here we actually do have. Oops. Here we have. I don't know if we do we have my screen?
Yeah, we can see it. We see the traversal.
Right. So this is another. Yeah. So this is another article on my blog that you can, if you're interested, you can probably find it. But the traverse function in itself looks like this. So this is created by on the async type from F#, because this article is like 4 years old now. But you could also do it with the task parallel library, or with the new task computation expression instead. But this is a general purpose function that you could just put somewhere in a module somewhere in your code, or you can probably find some library out there on GitHub that does this already. But basically, it just means that if you start out in this case with an option of something, and then you have a function that if that option is filled with something, then you have another function that returns an async. Then you can switch the order around. So instead of having an option with an async inside of it, you now end up with an async with an option inside of it. So that's basically the sort of problem that it solves. And that you can also do this for. So this is where knowing what a functor, knowing what a monad is, that starts to become interesting. Is that once you understand that this is a general purpose solution, it turns out that this thing. So right now it's just a traversal over options and asyncs, but we could also have here a list of things, an enumerable of A, for example, and then what we would end up having here is an async of an I enumerable of B. Or we could have, instead of this being an option, this might be a result. Now we'd have to write new functions for each of the types here, but the general idea is the same, is that if you have some sort of monad, so that could be option, that could be result, that could be, sequence, lists, arrays, things like that, or other things that are, traversable monads. It's not all monads, or not all functors are traversable, but a lot of them are. Then you can sort of make this, standard function called a traverse function, and then you have a solution to a wide range of problems. So I'm going to switch back so I can see you. So maybe you want to take my screen off again. I'm just going to leave it on for sharing. Is that going to work for us?
Yeah.
Yeah.
I mean, I think there was, again, it sort of made me think about the concrete cases there, because you had the transition from, now which way was it? Async.
There was option from.
Yeah, option of async.
I start with an option, and yeah.
Because it wouldn't work the other way around, right? If you were going from
if you already have a task and then you want to do,
yeah.
I'm sorry?
If you had, I'm just trying to figure this out. If you had async of option, then you can't go to option of async, because that basically means evaluating the async first.
Yeah.
To figure out.
Yeah. So not all so not all combinations work, and we don't really have I'm not aware that there's an F# specific catalog of which things, which combinations are actually possible and which ones are not. What I usually do is that, because I also program in Haskell, what I usually go is that I go to the Haskell documentation of this thing that's called a traversable, and then I look up, which things are traversable, and then I know what that is. And that's, I listed a partial, list of that before. Options are traversables, results are lists, all sorts of sequences are, and I think you can even do it with trees if you want to. Can't remember, but maybe. So again, that's one of the things I wanted to look up. But as you said, task is not traversable, because that requires that you have to be able to evaluate it. And that's what we want to avoid here. So it's not all functors are traversable. So it also helps to know which ones you can actually do this trick with. And so again, knowledge of theory does help you a little bit, because it can also save you from a lot of trouble, trying to chase down a solution that just doesn't exist. If that makes sense.
I think that does make sense. I mean, it's, yeah. I think you have to really sort of reach that point where you see the sense by sort of going through the. You can't sort of start with not knowing what these things are, going to the I see the point, and then learning the technical details. You really have to sort of start with, I've got no idea. I got the technical details, and
right.
I'm quite sure. And then you see the sense of all that, which maybe relates to one question that we got from the audience here, which is Monads. Hang on, where was it? Is there a real life F# project which uses free monads? So have you ever used those in a real life F# project?
No.
I think that
I'm sorry.
No, continue, please.
No, I had this. I have a few toy examples on the blog, and the article that I just showed people is one way to start there. Just find my blog and go, search for free monads in the archive. It's fairly easy to find. I've never used it in a real project, and I haven't seen it either, because it's not really. I don't consider it idiomatic for F#, but you definitely can. But I'm not sure that there's much reason to do it. What I usually try to tell people is there's this other idea from there's an architectural style called functional core imperative shell. And another way to view that is what I usually try to explain to people is that it's sort of like a sandwich, where you start doing some stuff that's impure in your entry point. And then once you've collected all the data that you need for calling a pure function, you call your pure function, and that pure function, it sounds like it's just one function, but it might be composed of a lot of code, pure functions calling other pure functions, and that pure function returns some pure data, and then the third part of the sandwich is then that now you go and do some other impure things with that return type. So that's where you can write things to your database or show things on the screen or whatever else you want to do. So a lot of applications today have small scale entry points, in the sense that every web service, for example, has every HTTP request that comes in is being handled by a controller or something like that. So basically what you have there is you can do that little sandwich thing where you say impure, pure, impure, and that stuff, usually an HTTP request is something you need to handle in sub-second timeframes anyway. So so you can, if you organize things the right way, you can often do that. So the thing that I find interesting with this is that you don't need to understand anything about free monads. The way you avoid having to use something like dependency injection or having to use something like a free monad is to try to see if you can reorganize or reframe the problem that you have in such a way that you can use that impure, pure, impure sandwich, because then you don't need all of that fancy machinery. And what I've figured out so far, I've been doing this for over 5 years now, and I've try to figure out what are the limitations of that style of programming. And you can come up with some advanced scenarios where that's not possible, but it is surprisingly often possible to organize your code in that way. So people often come with this question, but what then if I need to, I do an impure thing, and then I, do a complicated pure calculation, but then based on the result from that complicated pure calculation, I need to go and query something else, from a database, from a web service, or whatever it is. And that's always it's always a question put in the abstract. And once you start to look at, okay, so what's your actual concrete problem, it often turns out that, oh, maybe you could actually just have prefetched that data beforehand, even though you don't know exactly what the inputs is going to be. And then people say, oh, but there's going to be so much data that it's prohibitive. And then I say, okay, so how much data are we actually talking about here? And then we make a little bit of back on the envelope calculations, and we figure out, oh, we're talking about 2 megabytes here, and then then I say, okay, you can make your code structure much simpler if you just go and prefetch those 2 megabytes, even if you don't always need them. Just prefetch them and then pass them as an input argument to your pure function, and then your code is going to be much simpler. It is surprisingly often possible to do that.
I mean, I haven't done this, but I think I do have a case where this would actually be useful. So if I can get my screen on, then this is a sort of fun project I did, which is a emulator of Commodore Basic, and I mean, I think this is interesting. Hang on, let me run this. This is interesting because it's really very interactive. So you sort of type in keys, and it has to wait for your keys, and then you can kill it if you're lucky. So this is the case where it really sort of, you have to it does some computation, like emulates your basic code, but then it has to wait for keys. Yeah. And the way this is, I mean, well, first of all, this code is somewhere on GitHub. Don't look at it because I've written it in a week, and I never tried to tweak it. Yeah. But somewhere in there's this structure which represents the sort of computation, which I think you could probably rewrite with free monads, because it has this structure of, now I'm waiting for some action to happen. So for example, this is when I'm waiting for a key, I'm in some state, and then I sort of have to wait until that state gets updated by the system that lives on the outside. And then I get the state together with the key that was entered, and I continue the computation. So I think this is a case where the abstraction could actually work. But in this case, I just felt it's much easier to sort of write it straight away. But I do imagine if you know those abstract structures, then that can help you understand this design, and maybe sort of figure out that that's the structure of a problem you're having.
Yeah. So right now here you have used the AND keyword in order to be able to define the states and the resumption type, where they have circular dependencies on each other. But what you actually could have done is, or at least, I mean, I'm just seeing this right now, so I might be off here. But what I think you could have done is you could have defined resumption as a generic type, and then that would have been a functor, and then this looks very much like the type of functor that you then turn into a free monad by elevating that into that free recursive data structure, and then you could have avoided the AND keyword. But then again, it's one of those things where I completely agree with you with what you said here, is that once you understand some of those more abstract theoretical things, stuff like that starts to become very easily recognizable. I mean, I think even though I haven't seen your code before, I think I have a pretty good grasp of what the idea behind this is.
I think that's probably good point to end with, because we've used all our time here. Let's have a quick look to see if we've got any more questions. I don't think there's more. You can, I mean, people can probably sort of keep chatting on YouTube, and maybe we can ask you to have a look and see if there's any questions there.
Oh, we're on YouTube as well. I'm sure that I'm going to find the link then. Okay, I'll have a look.
What's your conclusion then? Are free monads as a sort of substitute for any interesting abstract concept? Is this something that people must learn now?
I think, well, not free monads, but I think you really do yourself a service to understand that there's something called a traversable functor, and you don't have to, be able to do it, in your sleep, but just knowing when you run into a particular set of problems, go and Google with Bing, traversable F#, and then you can probably find some good solutions to that particular kind of problem. I think that's probably the key takeaway here. This is the problem that I run into most often, or that I see other people having. So that would be a good tip.
Thanks. I think that brings the two opposing perspectives that I was trying to start from back together. So we can agree on that. So thanks again for joining us. Thanks for an interesting conversation.